In this video, we're going to talk about how to calculate the area of a sector, right? So let's just start off by reminding ourselves again what a sector is, right? So we have this. This is our circle. Our circle always has a circle always has a radius, right? So you have this, and then you have that. Essentially, a sector is the slice of the circle, right? So you have this radius, you have that radius, and then we have our angle theta. And we've been working, with radians. We hopefully at this point now have a reasonable understanding of what a radian is. But in this case, we're basically calculating this area over here. All right, that area. Not the best shading, but it will do. Okay, so calculating that area. So we're going to call this A, right? So we're going to call this A for area. Thought I'd gone back to the pins. We're going to call that area A. Now, our understanding of what formula we're going to use comes from, again, ratios. It's based in ratios. So what we're going to do is we know that usually, in order for us to calculate area, we usually say pi r squared, right? So we know pi r squared. So if I say the ratio of the area of a sector to that pi r squared, which essentially is just the area of the full thing, right? So we know that this is pi r squared is the area of the full circle. So this is going to be, you only take, this is the area of the small piece, and this is the area of the full circle, right? So the area of this ratio should be the same as the ratio of your theta, right? Which is just the angle of that small piece divided by the angle of the full thing. Now we know that the angle of the full thing in when it comes to radians is 2 pi, because we came up with that in previous videos, because we know that 360 degrees equates to 2 pi radians. So this is the ratio of areas, and the top one gives us the area of the sector. The bottom one gives us the area of the full circle. This side is the ratio of the angles, right? So this is the angle of the sector, and this is your angle of the full circle. These ratios have to be the same. So if I take half of my angle, right? So let's just say I'm working with 180 degrees or pi radians. It should also be equal to half. That means the area as well of the sector is also going to be half of the full thing. So the area of, the ratio of the areas should equal the ratio of the angles. If that makes sense. So that's where we start, right? So we're going to rewrite this as A is equal to pi r squared. That's equal to theta over 2 pi. Now we're trying to find the equation for A. So we're going to say A is equal to, so we're going to multiply both sides by pi r squared. It's going to cancel the pi r squared on this side, but now you have to do that to the right hand side as well. These pi's are going to cancel, and what you're left with is this over 2, which is the same as saying half, right? Because the 2 is the denominator. So it's the same as saying half. We still have r squared over here, and we have a theta. So this is the area of a sector, and it only works with radians. Ooh, horrible, horrible. Right, which means if your question is given in like degrees, you might need to do some conversion. The reason why it does so is because this 2 pi is radians. If it were degrees, would need to make this 360, because that's the angle of your full circle. Angle of a full circle in degrees is not 2 pi, right? So the formula changes if it were degrees. So yeah, so this can only be used in radians. So that is the formula that we need to now remember going forward. And its area is half r squared theta. If you want to highlight that in your notes, perfectly fine, right? So now that we know what the formula is, now we're going to jump straight into some examples. right? Jump to example number 1. Example number 1 says, right, we have this sector, right? I'm hoping that this is going to give me like a nice curve. Sure, that works. It's okay, right? Straightforward question. Your angle is pi over 3. This is 2 meters. What is the area? So area in this case, A, is half r squared theta. We have our r. That's perfect. Our theta, always make sure that it's in radians, and it is. Right, so now we can use this directly. So that's going to be half of 2 squared multiplied by pi over 3. So 2 squared over 2, that's 2, multiplied by this, that's going to give you 2 pi over 3 meters squared, because remember, it is area. All right, cool, nice. That's your example 1, a simple example just to show you how to plug and play. Now, let's move on to example number 2. Example number 2 is a little bit weirder, but the concepts stay exactly the same, right? Where you have a circle. A circle has a radius, right? So the radius is going to go there, and then it's going to come down. And it's not really at the center, but, you know, we'll make it work. Then we're going to draw a line over here. Let's just pretend that this goes up there. We're going to make this 2 again, 2 centimeters this time, though. And then maybe let's make this pi over, no, we'll make this 1 radian. That's your angle. Now we're trying to find the area of the shaded region, which is going to be this region here. This little part of the circle. Right, so now we need to get into gear and start to think more about breaking down the shapes. Now, if we're going to break down this shape, we know that this whole section from here, down there, and then back up here, that's your sector, right? Maybe let's label to make it a little bit easier. This is going to be O, this is going to be A, this is going to be B, right? So we know that this is going to be our sector. This whole thing is our sector. And we also know that this is a little triangle that's inside here, right? So in order for us to get this area over here, we'll take the area of the full sector minus the area of the triangle, and then we'll subtract those two. So let's get those, right? So let's actually just go shaded area is equal to area of sector OAB minus, because inside it we have this little triangle that we don't want to consider, but the triangle is also triangle ABC. I mean OAB, area of triangle OAB. Okay. Right. Now, how do we calculate the area of the shaded region? I mean, area of the sector. In order for us to calculate the area of the sector, we're going to go half r squared theta, which in this case, fortunately, is very straightforward because we have our r, which is 2 centimeters. We square that. We multiply it by theta, which in this case is going to be 1 radian. So this answer is actually pretty straightforward. 4 over 2 gives us 2 multiplied by 1. That gives us 2 centimeters squared. The area of the triangle, when you're hearing me kind of mouthing like signs, I was trying to remember the area of a triangle using the sine rule. And sine rule basically says this, right? If you have a triangle and the triangle has 3 things, right? You have theta, you have this side, the 2 sides that basically form to make that angle. In order to find the area of this triangle, you would say half the 2 sides multiplied by sine of that angle. Okay, so that's what we'll do, because in this case we have this triangle, we have this angle here, which is 1 radian. We know that the 2 sides that come together to make up that angle are the 2 radii. So that's 2 centimeters on this side, 2 centimeters on that side, right? So we can now use half of AB, which is basically going to be Let's actually just write AB, and then that's going to be sine theta. Now in this case, our A and our B are both R. So that's going to be R times R, which is R squared. And then sine theta, right? This is going to be sine theta. Now remember, our theta is actually in degrees. The moment you see this, you change your calculator to radians. Make sure your calculator is in radians in this case. Because if you put a degree, if you put sine 1, because our angle is 1, put sine 1 and your calculator is in degrees, it's going to give you a weird answer. So make sure your calculator is in degrees. So that's going to be half of 2 squared multiplied by sine 1, right? Which is the same as 2 squared times, 2 squared is 4 divided by 2, that's 2. So I'm just going to write this as 2 sine 1. And then punch that into our calculator, make sure that it's in radians. 2 sine 1 is 1.68. Okay, right. Therefore, the area of the shaded region is equal to the first area, which is area of, or the 4 sector, that's going to be 2, minus this little area that we then remove, the area of the triangle that we remove to then stay with the shaded region. That area is 2 sine 1. If you subtract these and you get a negative value, you've done something wrong, right? So I'm going to punch it in, 2 sine 1, 0.317, just write it at 3 significant figures. When all, this is actually supposed to be centimeter squared. When all else, when it's ambiguous, just write the 3 significant figures. And that's our answer. Right, I was going to go through another example here, but so that the video isn't too long, I'm going to stop it right here. And then in the next video, we're just going to go through one other example that's a bit more complex than these. And then from that point, it is just exam problems, and more exam problems, and also feedback. If there's something that's still confusing, please do let me know. But for now, I hope this video made sense, and I'll see you in the next one.